of 5. Now I have a question for you. Is it easier to count the cards that are above a 5 or the ones that are not? Not. So let's do this as a not, one of the not ones, because there are fewer cards in the not category. So this is going to be 1 minus the probability of not above a 5. How many cards are not above a 5? She says 4. Do you guys agree? 4 types. So when you're counting those, what are you counting? The 4, 3, 2. Wait, what are we counting? What kind of cards are we counting here? Below a 5. So we're not. We said not above a 5. Is that really below a 5? So we. Right. So he told me I have to. When I was doing above a 5, I'd start at 6. So when I'm doing not above a 5, I should start at 5 and work down. Because 5 is not above a 5, is it? Yeah, it is. That's why I wanted to do this way. 5 is not above a 5, yes? It's exactly equal to. So that one gets to count. And then nobody has any question about the 4, the 3, the 2. And so we've got a 5, a 4, a 3, a 2. So there are 4 types of cards. And there are 4 suits. So in total it's 1 minus 16 over 52. Which if I get my common denominator, I have 52 over 52 minus 16 over 52, which is 36 over 52. That's part of the reason I wanted to put that one in is because when you're thinking not above a 5, that's not the same thing as being below a 5. Because 5s count here where they don't count in the below part. All right. So we're moving on to this question. Here's our question. I have an event. The odds of the event are 1 to 6. What are the odds of the event not happening? So that's the odds of the complement of the event. All right. How many of you are going, I don't know what she's talking about? Feel free to raise your hand. Okay, see, Jessica can be honest. Good, good, good. Okay. Remember about odds. The odds of an event are successes to failures. Yes? Not 5. So when I'm talking about the event not happening, so this was how many ways the event could happen, right? Then what would this have been? It's the rest of the stuff in my sample space that's not the event happening, right? Yes. All right. So I got it. Yeah. Let's go back a minute. So. I think I gave you almost everything you need for this. I just have to find out for sure. The odds of an event, I told you this on Tuesday's class, are equal to the number of things in the event, colon, the number of things in the complement of the event. That should be in your notes somewhere. Another thing that this means is this is your success, that's what happened, and these are your failures. So in the case of our problem, there's 1 way to be successful and 6 ways to fail. So what are going to be the odds of the complement of my event? Well,
1 to 7.
not 7. Think about this. So here, the in my event to the number of things not in my event. Here, the odds of not having my event not happen should be, well, here was E, there was E, so what should be here? No, what's, should it be E? It should be not E. Yes? Then, what should be here? Here should be the E. So what happens to my numbers? Because the number of things in E was 1, the number of things not in E was 6, so the number of things not in E is? This is a different question. The difference here, so this is the original question that I have up there. We were said the odds of an event were 1 to 6. And we told you this is how you find odds. It's the number of things in your event to the number of things not in your event. Also referred to as successes to failures. So there was 1 way to succeed and 6 ways to fail. So then this question adds the complement, the not in the event. So the odds of not being in our event is going to be the number of things not in our event to the number of things that are. So then, now the number of things not in our event we found out from the original part was 6, and the number of things in our event was 1. So the odds for complements just switches the numbers around. Because what had previously been a success becomes a failure, and what had previously been a failure became a success. Just switch the numbers. Now, in my last class, somebody said, okay, there's a problem like this in the homework, and how many of you have gotten to it where it asks about here are your odds, what's the probability? You guys remember this one? It's not in 3.3, it's actually in 3.2. You guys remember it? Some of you are going, yeah, others of you are getting this look. So then, here's another question related to this. If we know that those are the odds, what is the probability of my event usually happening? 1/7, because these two numbers add up to everything that can happen, and remember that's our total. So you guys were a little speedier than my first class. You guys have been looking at this going, oh, I already know how to do that. Don't tell us. You are looking at this. This is the little piece of paper you have. Nice come up a lot here. The way you should be reading it is the diagonals